Start.
Hi, my name is Dr. Prof Burman and I am an assistant professor in Department of Applied Sciences at BML Munjl University. So this university is in Haryana state in India. It is very close to the capital city of India, New Delhi. I have been working here for last 5 years in the Department of Applied Sciences, and I have been teaching chemistry to undergraduate students. So these undergraduate students that I am teaching chemistry to, they are going for getting their bachelor's degree in technical subjects like civil engineering, mechanical engineering, computer science. So I am teaching them the introductory chemistry. Also I am doing research in the area of photocatalysis for applicable towards water remediation as well as hydrogen production from water through photocatalysis. About myself, I did my PhD from Kansas State University. I graduated in 2010. I did my PhD under the supervision of Dr. Christopher Levy in the area of asymmetric catalysis. So in Kansas State, I have synthesized a lot of asymmetric complexes, chiral complexes, which act as a catalyst for different organic transformations such as sulfoxidation, epoxidation. After PhD, I joined Dr. Eric Anselin's lab at the University of Texas at Austin. There I have worked in the area of supramolecular sensing, and since 2014 I have been working here at BML Munjl University. So today my job would be to talk about these two terms, organic chemistry, two words, and to make sure that the students understand what is the importance of organic chemistry in their own domain at the same time as a future career prospect. So the term organic chemistry, which consists of two words, organic and chemistry, for an undergraduate student is like a nightmare to most of the undergraduate students, because it consists of lot of difficult concepts and students feel pressure to understand those concepts. At the same time, this is a prerequisite for them to carry out their own discipline. Maybe it is pre-med students or engineering students, they all have to take that subject. So it's something looks like this scenario, student feels burdened. But today, let me tell you why I love this subject, organic chemistry, and let's see whether I can also make you understand the importance of organic chemistry. So this is the molecule epinephrine, which we produce inside our body, which has a name such as adrenaline. So this molecule is also act as a drug in our life-threatening situation. So this molecule, it's sold in the market such as in this kind of thing, which has an injection at the bottom. So whenever we have a life-threatening situation, be it an allergic reaction, be it our heart stop pumping blood and all those things, so we just inject this drug in our thigh and it can save our life. So this is a miracle drug. So this is nothing but organic chemistry. So if you look at the molecule which does this magic, it looks something like this. So it is completely not understandable to many of the people who did not study organic chemistry, but this is something which can save our life. So let me tell you, this molecule is being taken out from the adrenaline gland of the sheep, that is a natural source, but actually the scientist, the chemist, we make this molecule in the laboratory by means of synthetic organic chemistry, where we do synthesis of this molecule starting from small parts which are naturally occurring. So this molecule, let's talk about this molecule a little bit more and make you understand what it means to you other than just showing some lines and some letters. So this molecule to a normal person does not mean anything. It is just some lines and some atoms, right? Letters. So if I have to draw this molecule in the board, it looks like this, where this is something called a phenyl ring, which is joined by carbon-carbon bond. Carbon has a valency of 4, so it has to bond to 4 different atoms, and there is a triangle, solid triangle with an hydroxyl group OH, and there is OH, OH. So whenever there is two lines are joining, this is joined by a carbon, and since carbon has valency 4, so it has to have satisfy the 4 valency. One here is a pi bond, sigma bond, another sigma bond, third sigma bond, and the fourth valency would be satisfied by joining to a hydrogen. So whenever the joining of these two lines, there are carbon, and carbon is having 4 bonds, so it has to go for 2 different hydrogens to attach. Now the significance of this solid triangle means there is a carbon here which has 1 bond here, second bond here, third bond is this solid triangle, and the fourth bond is a dotted bond bonded to a hydrogen. So hydrogens are not being shown here, as well as the carbons are not being shown here, but this center has a particular significance in the effectiveness of this molecule as a drug, and this center is called a chiral center. A chiral center has a particular property, and the property is that it can interact and rotate the plane of a plane polarized light. So it can interact with the plane polarized light. So since this is a molecule, if I show you in the 3 dimension, it looks something like that. This also, this is not 100% accurate because there is no such pi bond here. This is more like a cyclohexyl ring, but if there are pi bonds, this is a 2-dimensional planar. But now you look, if we see these bonds, the carbon, carbon, nitrogen and carbon bond, these bonds are like one single line goes in one direction. So this bond can actually rotate something like this, and this carbon center has 4 different atoms joined to it. So this is called a chiral center. So this has particular importance, as I said. So how do you know that this molecule actually has this form, right? The carbon is joined to this carbon, and this carbon is joined to this carbon, and the carbon is joined to a oxygen. So nobody has seen this molecule. These molecules are really small, so no such instrument can observe this molecule. So there are some sophisticated techniques such as nuclear magnetic resonance spectroscopy or NMR spectroscopy, which can confirm the presence of this molecule. If we have to know how many molecules are there in this tube, there are like 10 to the power 18 number of molecules in this tube. Do you know how many people are there in this earth? 7 billion. So it is like way ahead, more than that 7 billion number of people. So this number, if we have to visualize, this is like if we can bring all the sand grain in the entire earth in one place, that is like would be this much number, and that is the number of molecules in this tube. So this molecule has only carbon, oxygen, nitrogen and hydrogen. These are the 4 atoms. So you all know about this periodic table. So if we look at the periodic table, there are many elements. There are like 118 elements, but only this carbon, nitrogen, oxygen and hydrogen are the essential elements for life or for organic chemistry, say for example. Apart from that, there is phosphorus and sulfur as well for the organic chemist, but this carbon, nitrogen, oxygen and hydrogen, these are the 4 elements or atoms which are most prevalent in any organic molecules. So let's see the different organic chemicals which always encounter in our day. So the day starts with a cup of coffee, right? So coffee has 4 different molecules which are really essential in coffee. So one of them is caffeine, which is responsible for us to wake up from the bed. Second is that we all know our favorite acid, citric acid in lemon is there. Third is the chlorogenic acid. This is the acid which is responsible, has a great antioxidant property. And the next one is the phenol, which is responsible for the bitterness of the coffee. So if we even look at these molecules also has only these 4 atoms, carbon, oxygen, nitrogen and hydrogen. So organic chemistry is everywhere. We have to all understand the importance of these different bonds, how they are formed, what is the valency, how they react with our body. Okay, one more drug is Taxol, is anti-cancer drug, is also a drug which has been discovered from a natural source, from a tree, natural source, from a bark of a tree in Pennsylvania. At the same time, it's a potent anti-cancer drug for ovarian cancer. If we look at that this molecule also has carbon, oxygen, nitrogen and hydrogen, these 4 atoms. And if we have to explain this molecule takes like years to make in the labs, in the synthetic lab in organic chemistry. It has so many chiral centers. So whenever there is a dotted bond or a solid bond, solid triangle, this means this center has a particular importance as a drug, and this is called a chiral center. I'll show you one more drug. So this is in 2 dimension. The drug looks something like this in the 3 dimension. If we look at this molecule, each of these chiral centers has a particular orientation in the 3 dimension, and that particular orientation is responsible to interact with the cause of the disease. The other orientation does not. Okay, so one more example is that this drug is being sold in the market in the name of immunoprine, and this molecule has one chiral center, which is this. So the chiral center has the property of interacting with the plane polarized light. It can move the plane polarized light in 2 different directions. So depending on the direction, it has a particular name, either a conformation called R or S. So if one of the conformation is R, the other one would be the S conformation. So one of the conformation of this drug effective as a antidepressant drug, whereas the other enantiomer chiral molecule causes Bird's defect, so it's not a drug. So organic chemists are having huge importance in our life. So organic chemists are like the blacksmith of a Iron Man, but without that blacksmith, the man looks like this. So organic chemist has a huge importance, and this Iron Man is nothing but our physicians, right? So without the help of the blacksmith, the Iron Man would not be the Iron Man, would be a normal man. So organic chemist has a huge importance. So let's talk about its simple topic, atoms and molecules. Now the chemistry is everywhere, right? And let's take few examples of the chemistry around us. Like let's take rust. It has a particular property, brittle. Let's take diamond, it is very hard. Let's take graphene, it has very high strength. Let's take gold, it has a particular property that is non-reactive. Then aluminum, lightweight. Copper conducts electricity, right? Also it is ductile. Now why these different properties for different materials? If we look in a microscopic property, then we will see next slide. So now every material is composed of molecules or atoms, and the molecules actually are the fundamental building blocks of the matter, and the molecules are composed of atoms. Atoms are composed of nucleus and the electrons on the outer shell, and the electrons and neutrons are protons and the neutrons are stick together to form a nucleus. That is the heaviest part of the atom. Electrons are almost massless, and the proton is positively charged and the electron is negatively charged. That's why the atoms are neutral, and the diameter of the atom is around 1 to 10 angstrom, and the diameter of the nucleus is like 10 to the power minus 4 angstrom. So you can see there is a large hollow space surrounding the nucleus in which the electrons actually reside. Now we can further break down the protons and neutrons into quarks and gluons. Let's first talk about the discovery of the electron in a nutshell, that the charge of the electron and the charge by mass ratio of the electron was first discovered by J.J. Thomson in 1897. What he took is that he took a partially evacuated glass tube and he put a cathode and a anode material, and he applied high voltage around the cathode and the anode. What happens is that the ray of particles came out from the cathode towards the anode, and then he accelerated the particles, and these particles fall into the fluorescent screen, and he applied an external electric field and a magnetic field, and the particles position can be changed varying the electric field and the magnetic field. What we find out is that the charge to mass ratio of these particles, which are electron, is this much, and the charge of the electrons also can be found out. Then the discovery of the nucleus came, where Ernst Rutherford, he took a very thin gold foil and he bombarded this gold foil with a source of alpha particle. So, alpha particles are nothing but the positively charged helium atom, and when the alpha particles strike this gold foil, very few of them get deflected. The majority of them get undeflected and fall onto the fluorescent screen, which shows that the most part of the atom is hollow and the little part has a nucleus where they get deflected after bombarding. And then today's time, we can actually measure the atomic mass of each and every atom through a technique called mass spectrometry. This is nothing but we spray the sample solution, and there is a voltage difference, and the sample is being evaporated into the gaseous form, and this beam of electron, they actually knock off the outer shell electron from the atoms, and then these atoms will be positively charged, and depending on the mass of the atoms, they can get deflected on the magnetic field, because this mass the atoms are now charged, positively charged, and we can find out the exact atomic mass of every element. In the recent past, atoms could be imaged, is shown by IBM with a scanning tunneling microscopy. So, it is a imaging of the iron atoms on the copper surface. So, if we image, it feels something like the iron atoms actually have a position like this on the copper surface. So, fundamental particles are atoms and molecules. So, if we take 100 grams of the copper carbonate, then we can get 51.5 grams of copper, 9.7 grams of carbon, and 38.8 grams of oxygen. If we take the double amount of copper carbonate, we get double the amount of individual components. So, it shows two things. It shows that the total mass is conserved, which is 200 gram in this case and 100 gram in this case. At the same time, it shows that the individual elements, they combine in a definite ratio, a particular ratio, to form a molecule. So, this comes to the law of definite proportion, that in a compound, the component elements has a definite ratio by mass. So, in conclusion, that we can conclude that all matters are composed of atoms. Atoms are the most fundamental particles, elements, and atoms combine in integer numbers to form a molecule, and molecules are the fundamental particles of the compound. So, that is the conclusion. If you need any help or anything, question you have, this is my contact number. So, please feel free to contact me. Thank you so much.